So remember our discussion of the Bohr's model. While we are going to move away from thinking in terms of that model, there is one general structural feature that we can find helpful in this case. So remember, in the center we have the nucleus, and then somewhere we have an electron, right? And so what we can think of, right, and remember, first of all, this is actually supposed to be three-dimensional, so we think of this as a sphere instead of how I'm drawing it as just a circle, right? But this is actually a sphere, and the electron, for instance, can lie in an orbit anywhere around this sphere, okay? And so if we draw a line, a vector in between, right, the nucleus and where the electron is, okay, then we have some radius r, right? We can define the length of that vector as a radius r. And so what it turns out then, again, is if we think of this again as a sphere, we can convert, instead of using x, y, z coordinates, right, to tell, to describe the position of the electron, we can instead use the nucleus as the point of reference of the origin, and because we have we were thinking of the displacement of the electron in terms of a sphere, we can then convert that to spherical coordinates. And instead we would have a set of terms that describe the position of the electron in terms of r, theta, and phi as such, okay? And so on the board here, we can see a depiction of what those terms actually mean. So again, we have this set up with x, y, z axes. So the z-axis goes straight up, y comes in the plane of the board here, and x is perpendicular to the plane of the board. If we take a point, which we mark as x, which is on the figure here, we can instead convert that to a set of spherical coordinates, where we have a radius, which is the distance between the origin and where the point is. In this case, we're going to use that as where the electron is at any given time. And so that r will tell us the distance from the origin, distance from the nucleus, distance of electron from the nucleus, okay? Theta, right, is going to be the angle between the z-axis and the vector that is drawn between the nucleus and the electron. So angle between vector and z-axis. Right? And finally, we have phi, right, which is the angle between the x-axis and a point that is extrapolated, or that is projected from where the electron is down to the xy axis. And this is seen more clearly on the figure here, but oops, put this up here. Oops, a little bit higher. Phi, that's the angle between the z-axis, sorry, x-axis, and the vector r, defined by r, okay? And so using these instead, we will be able to make the math for looking at the distribution of the electron using the wave function a lot simpler, and we'll discuss about the components of that in a second.